Hello everyone. Today, first of all, we will do dissociation of water. The dissociation of water. Then we will understand three situations of aqueous solutions. Then some more about pH scale, and finally we will do pH calculations. Actually, all these come in class of acid base equilibria. Okay, so first of all, let's do dissociation of water. Now, water, as we all know, pure water is a weak electrolyte. But still it ionizes to a very slight extent. So ionization of water we can write like this. Since it's a weak electrolyte, we will have an equilibrium sign because the reaction will be reversible. Now equilibrium constant for this, again we can write down as, you know how to write down the equilibrium constant, it's product over reactants. Now this is also aqueous solution. In aqueous, so you can write down this. So that will be product over reactant. This is liquid, right? This is how we write down the equilibrium constant. Now I can take this water to right hand side like this. Right? Now since water, it ionizes to a very slight extent, so the amount of water that is not ionized is effectively constant, means its amount or its value will not change to a very prominent amount. That is, we can just ignore this water, we can just neglect this. So we can rewrite this Kc water this equation as this is also constant and this is also constant. So now we can rewrite this as Kw is equal to hydrogen ion. Remember, this is aqueous, okay? You can write down aqueous every time. This is aqueous. Okay, so where this Kw is known as dissociation constant for water, right? So at room temperature, that is 25 degrees, Kw, it has a fixed value, that is 1 into 10 raised to power minus 14. So for neutral water, hydrogen ion concentration will be equal to hydroxyl ion concentration, right? So if you have to find out hydrogen ion or OH ion concentration, it it will be just square root of this, because since both these hydrogen and OH ion concentration are constant. So for neutral water, OH ion and H ion concentration will be 10 raised to power minus 7. That's a fixed value for neutral water. Now let's discuss 3 situations for aqueous solution. So for aqueous solution, again at room temperature, that is 25 degrees Celsius, H ion, if H ion concentration is more than OH ion concentration, remember I am talking about aqueous solution. So it's acidic. The solution is acidic solution. Remember, these are aqueous solution because an acid is acidic only in aqueous solution, or a base is basic only in basic solution. Aqueous solution. Similarly, if OH ion is more, the solution is basic. It's basic solution. If both are equal, it's a neutral solution, right? So in neutral solution, H ion is equal to OH ion, that's 1 into 10 to the power minus 7 moles per liter, because for concentration units are moles per liter. Now in acidic solution, it's greater than 10 to the power minus 7. In alkaline solution, OH ion concentration is greater than . Now next is pH scale. Now pH, we have pH like -1, 1, 3, 5, 7, 9, 11, 13. Now for this hydrogen ion concentration, it's 10 raised to the power 1, 10 raised to the power minus 1 for this, 10 raised to the power minus 3 for this, 10 raised to the power minus 5, minus 7, minus 9, minus 11, minus 13. And OH ion concentration for this will be 10 to the power minus 15, minus 13, minus 11, because their total should be 10 to the power minus, means when you multiply these, this should be 10 to the power minus 14, right? See here in this H ion and OH ion, if you multiply these, this comes out to be 10 to the power minus 14, because total Kw, you know, it's 10 to the power minus 14, right? So here when it's minus 5, this will be minus 9, minus 7 here, minus 5 here, minus 3 here, 10 to the power minus 1 here. Then if you have 15, you will have 10 to the power minus 15 here and 10 to the power 1 here. This is about pH. How we find out pH? We discussed this last time also. pH is minus log of concentration of hydrogen ion, hydronium ion. And the inverse function for this is, the inverse function is hydrogen ion aqueous is equal to 10 raised to power minus pH. Clear with this? Now let's start with pH calculations. pH calculations. Suppose we have to find out pH for neutral water. Neutral water at 25 degrees. Now, for neutral water, you know H ion, we have already discussed this. These are equal. And suppose let's take this concentration to be X moles per liter. Now you know this X total is 1 into 10 raised to the minus 14. X square, right? Because 1x means just hydrogen ion or OH ion. So x square is 10 raised to the power minus 14. So therefore x is 1 into 10 raised to the power minus 7, and obviously this is in moles per liter. So pH is equal to minus log 1 into 10 raised to the power minus 7. This comes out to be 7. So for neutral water pH is 7. Okay friends, that's all for today. Next time we will do some more calculations on pH.